There are effectively two components for solving checkerboard ciphers. The first involves recovering the keys. The second is solving for the plaintext message as you would for regular simple substitution. That is, as a patristocrat with no word divisions or punctuation. But before that, there's an extremely special case that surfaces occasionally in fiction written around the 1910s. I won't give more detail than that, except to hint that we'll see a few examples in upcoming Ciphers in Fiction videos. We'll start with practice Cipher Cb1 from the last video. Cb1, 5x5, a very special case. We'll ignore the hint word because we won't need it. Say we have a simple alphabet square as shown. The alphabet is not keyed, the row and column keys are simply ascending numbers, and the alphabet is written in by rows. If we take the plain text A through Z and encrypt it as is, we'll get the cipher message 11, 12, 13, up to 55. This is effectively the Polybius version of a Caesar-shifted alphabet of shift 0 where A is equal to A. If we graph the normal frequency distribution using these digit pairs, we'll get this graph, which we've seen many times before when analyzing Caesar-shifted crypts. The only difference is the labeling for the x-axis. Okay, going back to Cb1, count up the occurrences of the letter pairs, ordering them as AA through EE instead of 11 through 55. We get these numbers. Putting this data into graph format, we can see that we have a pretty good match for all of our major peaks and valleys. We may have a bit of variation for each of our letters, but that's to be expected based on the actual content of the message. Anyway, I don't think there's a name for this kind of square. I nominate plain on by rows. We could also create reference graphs for plain on by columns, plain on by alternating diagonals, or any of the other standard routes. Right now, it should be pretty clear that Cb1 was encrypted with a plain on by rows square. Using the decryption steps given in episode 11, the checkerboard video, we get alphabet key none, row and column keys A, B, C, D, E, and A, B, C, D, E. Sometimes fiction writers will use checkerboard ciphers in their stories, but with unkeyed alphabets and A, B, C, D, E for the row and column keywords, or 1, 2, 3, 4, 5 for the row and column keys. Remember this for future reference. Moving on, I'm going to jump straight to the 6x6 Cb4. All of the steps described here will work just as well for 5x5. Keyword recovery can be a little easier for 6x6 because the numbers in the square can help point to the route used. Cb4, 6x6, when you hear the truth. Hint word, questions. The first step is to identify all of the letters that appear in the first and second positions of the pairs. Second, anagram them to see what words they can form. We get ACDENS and ADEFIL. 6 unique letters each, also pointing to this being 6x6. Using an online anagram tool, check the resources in the description below, the first letters can give us the words ascend, dances, or decans. For the second group of letters, we have afield and failed. We can eliminate decans as being an outlier, but the question for the other words is whether any of them share something in common. We can either pick dances and failed, or ascend and afield. This gives us 2 potential tables, and we can start out by testing both. We could try testing dances and afield and ascend and failed, but there's really nothing suggesting them as thematically connected somehow. The second step is to solve the cipher as a simple substitution. We can either continue working with the pairs, or replace them randomly with A through Z and 0 through 9. I'll keep the pairs because it will help illustrate the key recovery step, which goes hand in hand with recovering the plain text. Additionally, we can either place the hint word or go straight to testing the more frequent letters against the English ETAOIN pattern. Questions has a 1, 2, 3, 4, 5, 6, 7, 8, 4 pattern, or unique 1 pattern, depending on the system you use. So we want a repetition 5 pairs apart with no other repetitions in the block. First, we have an AD pair, but with a third AD in the middle, it doesn't fit our pattern. Second, we have this AE pair, which doesn't have conflicts, so this is a possibility. Third, we have this EF pair, but our full word space includes our valid AE pair, so EF is invalidated. Fourth is another AD pair, but this one includes a triple EL, so again, no good. Finally, we have one more AE pair, but that contains an AI pair, invalidating it. Filling in questions in the one place it will fit. Filling in the squares, we have NF is Q, CF is U, AD is E, AE is S, EF is T, SF is I, NE is O, AI is N, and we already have AE. It's a little bit early to make any definitive statements about the alphabet keyword or the on-by route. Returning to the cipher and filling in the known letters, there is a bit of a hint at TOTEIES. It's an odd coincidence, but the one letter that fits properly in the string of 3 ELs in a row is L, for to tell lies. Fill in the rest of the Ls. There's another odd bit at AEEF, AIEF, STNT. The STNT fragment may feel wrong until you remember that we can allow contractions, like N''T for not. Then something OU, something USTNT suggests you mustn't. Fill in the other Ys and Ms. The next block following you mustn't, something L, something YS, suggests always. Fill in the missing A's and W's. TEM something T looks like tempt. Fill in the other P's. This is almost fully solved. Looking at the squares now, ascend and a field looks more promising than danced and failed. Remembering that 1 has to follow A in the alphabet, the keyword is probably A1 NSWE5R for the word answer. There are 2 places the 5 following E can go, either at SA for an on-by rows route or at SD for an on-by spiral. The sequence QPOM is MOPQ backwards, supporting the conjecture that this is a spiral. If we assume that the full keyword is answer, then we can fill in the square and finish the message. Picasso, born in 1881, once said, "You mustn't always believe what I say. Questions tempt you to tell lies, particularly when there is no answer." The process for solving checkerboard ciphers combines understanding how words fit together in simple subs, minus the spaces and punctuation, along with the way the alphabet looks when packed into the square in different routes. Seeing alphabet fragments that run both forward and backward, up and down, can point to on by rows, on by alternating columns, spirals, or counterclockwise spirals. You'll get better at figuring out the actual routes over time with experience. I'll let you solve CB2 and CB3 on your own. If you need help, ask in the comments below or consider joining us on Patreon for additional support. That's all for now. See you at the next drop point. Got questions, comments, or suggestions? Leave them in the comments below. Enjoyed this video? Then I encourage you to hit the like button and subscribe to this channel. If you want to show further support, you can join us over at the Black Chamber Patreon page, where you can get access to more how-to videos and PDFs on solving the cipher types covered here, additional crypts to solve, and more. Links pinned in the comments below. See you at the next drop point.